Good morning students, I am Vetty Chelvi from Vetty and Vetty NEET Chemistry. Today NTA Abhyas 8 and 9 only the questions were selected. Topic is chemical kinetics. Okay, Abhyas 8, question number 15. Okay, the reaction is 50% completed in 2 hours and 75% completed in 4 hours. The order of the reaction is, so reaction is same. So for this here it is written. Okay, they are asking what is the order. 50% completed means 2 hours. We can take it as a T of. Now let us here written is a 100 is your initial mean with the 2 hours is become 50. It is I am taking the exact 50%, so we can take it as a T of. So 50 to 25, since we are considering a half-life period, that is 2. Okay. So now what we are getting is 2 plus 2, 4. Again it is given separate data, 75% completed. If you are starting with 100, we are ended with the left is, this is left is 25 mean, how much completed? 75% completed. For that what is the value is given by the sum 4 hours. So these two are matching, which is applicable for first order. So we can select this reaction belonging to first order. This is one way. What is the other way mean? Just I want to confirm our selection is correct. In kinetics, the data are following any reaction constant mean that reaction follows that order. That is the statement. For example, here the what is the rate constant equation written for first order I have taken. So now what I have to prove it, for two reactions the K value should be same. I have to prove because I have answered first order. Let us substitute here. Constant should be same. So for first category, 2.303 divided by 2, that is 2 hour log of 100 by 50 because it is 50%. 100 initial left. That should be equal to, that K value should be equal to 2.303 divided by 4 hour log of initial is 100. Here it is left. What is remaining? 75% over mean remaining 25. Now we have to simplify both things. Here it is getting what you are having is the 2.303 by 2 log 2. So what we are getting here is, you can cancelling here log 4. Log 4 you can separate and write as a 2 into log 2. Now this one you cancel. This 2 and 2 getting cancelled. So what we are getting having is now 2.303 divided by 2 into log 2. So what we are having is the same answer. So what is my knowledge is, what is the instruction is, this reaction, both conditions are giving the same constant value for the first order reaction. Mean that reaction is followed first order. That is the knowledge. So based on that knowledge, it has proved that changes are following first order. This is short trick. This is confirming. The thing is left to your choice. Now let us go to the next question. Abhyas 9, question number 44. The rate of a reaction quadruples when the temperature changes from 300 to 310 Kelvin. The activation of energy, or that is called the activation energy of the reaction is, they are asking energy of activation. Assume activation energy and the pre-exponential factors are independent of temperature, and then ln2 value is given or value in the unit of joules are given. Okay, now let us see here. Here what is the thing we have to follow the knowledge is, here the Arrhenius equation K is equal to A e to the power of minus EA by RT. Very important point is that data here you can see here children, it is given ln2, that is natural log value is given. So you should take this formula in terms of natural, that is in terms of ln. So ln, that is ln k2 by k1 is equal to, first you have to write for ln k1 is equal to A minus A, like that you bring it. So now you are doing the one equation by dividing other equation, you will get this format ln k2 by k1 is equal to energy of activation by R with the temperature. Why I am particular specific is, here you have to take it as a in terms of ln, not in terms of log. That is the point I am insisting. This formula is well known to you. There you will be misguided. So now let us go to next our work, ln. Next knowledge is the rate of the reaction is quadruples. That meaning what? 4 times it is increases is the meaning of it. That is English knowledge is required, of course, understanding. 4 times. So second equation rate is 4 times, and this is the rate constant of first equation is equal to EA by R value is given here in terms of joule. Sometimes it will be given in the terms of calorie also, depends upon the answer. So whatever value is given, you take it in terms of joule. I am taking into T1 into T2, it is the Kelvin, and here it is a difference in temperature, 310 minus 310. So you substitute the values and let us follow it. You want energy of activation, so you bring here. What is written is ln4, you can write as a 2 into ln2 into R value 300, 310 divided by 10. Next one, remaining things are mathematical only. How we have to do fast? Okay, this is. Next, what are the things I have completed is ln2 is written here. This is 2 into ln2, 8.314. This 300 I have written as the 3 into 10 power 2 EC for multiplication, and this is. The next one what I did is 0.69. You take it as a whole number, 0.7, and this is take it as 8.3. This is enough. Okay, what we are going to do first work is 7 into 2, 14, 1.4. Then this one is very simple, 8 3s are 24. You keep it there. So next one what I am doing is simple approximation I have approached here. You can see here children, 1.4 I have taken it as a 1.5. It is 24. You take it as a 25. 31. The one I am bringing here 30. Easy for multiplication. Now let us go to the multiplication. 25 into 30, you are getting the 750. 0 is the 3, 25 of 75, 750. Into 15, this one 1.5. This 10 power 2 is that. Further simple multiplication is 750 into 15. Let us go. Here I am writing this 0. 15 into 5. 15 5s are 75. Put 5 and 7. 15 into 7 is 105. On adding, you are getting the 112. So you are writing. Don't forget this decimal. You put this as 1. So now this is you are having, and here 10 power 2 is there. So to remove this one, I am putting 20. Now my answer is this is, here it is joules. Our answer is in kilojoules. Already I noticed. While I'm seeing the option itself, I have noticed. Because we have to verify calories also, that I have noticed it is kilojoules is mentioned. This is joules to kilojoules. You have to divide by 1000. So now my answer is, again you are repeating. First I am putting this decimal. Then I am converting into 100. So then divide by your 1000. This is joules to kilojoule. Our approximate answer is 113. Okay, now let us see joules. Now after this it's become the kilojoule. 113 kilojoule is our answer. Now let us see here children. This is you are nearing 113. Here it is far away from 113, and this is also. So approximation itself is giving the correct answer. Okay, again I am repeating here, very important 2 points you have to find it out. Based on the ln, selecting this formula. This is one work. Second work is quadruples. You are selecting, this is the second work. Remaining part are very simple only. Prepare well children. Thank you students.